guys ever notice how all I do is turn around and people start
Oh.
giggling and sneaky, and it's like they think they're getting away with something. You're in that list. You're on that list. And it's like you think that if I don't notice, that somehow you got away with something. And it's so untrue, because the reason something is bad is not because you get caught, it's that the thing itself is bad. For instance, like, let's just say you talk about somebody who goes out and does drugs, okay? And they don't get caught by their parents, and they don't get caught by the police. But have you read about how many heroin deaths there are?
Yeah.
And how many people are overdosing from heroin? Do you know that of the people in jail today, it's almost, not exactly, but it's very, very close to 100% of the people in jail are in jail because of something related to drugs or alcohol. Almost every person. Very few people are in jail because they don't have problems with those things. So you get kids who are like, oh man, I didn't get busted. Oh, you missed the point entirely. If some kid's like, man, I'm gonna hide my drug use from my parents. Well, pretty soon that drug use escalates into stealing. And then it escalates into bad decisions. And then you can harm yourself and your body and so on. I know two different people who had enormous amounts of money in the bank before they were 25 years old. And then they both had drug problems, and they completely wiped themselves out. They had enough money to start a business and to have a great life. And in both cases, they wiped each other out. They got wiped out completely. And here's the thing. In one of the cases, the person is older than me and still lives in the basements of houses, fighting and scrapping to pay rent. Not sure if he's gonna be able to go. Doesn't have a car. Can't have a car. Because every time he gets a car, he goes out and he drives drunk. And every time he drives drunk, he gets busted, and it costs him thousands and thousands of dollars in time in jail. So if you think that you do something wrong, and you think that maybe you think your parents didn't notice, or your teacher didn't notice, or somebody didn't notice, you steal something and you didn't get busted for it, you missed the point entirely. That has like nothing to do with the consequences of your actions. That's actually like a warning. If you go out, if you drink, or if you steal something, and you get busted, that's a good thing. Because it's catching you before it can become a really big problem. The problem is if you don't get busted, if it doesn't stop, then you have really big problems. There is, I can think of two kids who used to go to school here, this was back a few years, that I've received notification died of heroin overdoses. Maybe you know someone in your own life who died of a heroin overdose. And I'll guarantee you that when they first started using the heroin, they thought they were really, really cool and really, really with it because they were hiding it from people. And the truth of the matter is what they really wanted was for the whole world to know. Because if the whole world would have known, they would have stopped it before it became a really bad behavior. And you guys just got your report cards. And you look at your report cards, and you know if your report card was good or bad. Now, if you got a disappointing grade in here, and you think it had nothing to do with your behavior, you're out of your mind. Now, you don't lose points, Matt, for bad behavior. I don't like, oh, whoa, you talk to someone next to you, minus a point. I don't do anything like that. But you need to understand that the only things that are bad is when you're not paying attention. If you're doing something you're not supposed to be doing, you're not paying attention. And if you're not paying attention, you're not learning. And when you're not learning, then your grades will be bad, and then you will fail. So, I hope for your sake you get with it and you figure it out, because it'll help you in the long run. And ultimately, that's what matters. I don't really matter, you guys do. All right, the triangle has lengths, sides with lengths of 4, 7, and 10. Is this a right triangle? Now, the hypotenuse is always the longest side of a triangle. I'll just draw a picture here real quick. Okay. Here's the hypotenuse. It's always across from the right angle, and it has to be the longest side. So that would be 10, and this would be 4 and 7. This is a 10, not a 1.0. So does leg squared plus leg squared equals hypotenuse squared? Let's see if it does. God bless.
Yeah.
If it does, then that means that yes, this is a right triangle. If it doesn't, then no, it's not. So 4 squared plus 7 squared is equal to 10 squared. Let's see if that's true. 16 plus 49 is equal to 100. I add those up, I get 65. Does 65 equal 100? No. Therefore, this is not a right triangle. Okay? All right, next one. Greatest rate of change. What's another word for rate of change? We talked about this yesterday. Guys, what's another word for rate of change? Come on, we talked about this. You guys should be nailing this. Oh, maybe you weren't paying attention. Maybe if you had paid attention, you would remember this. And then there wouldn't be the bad side. And maybe you thought you got away with something yesterday when you didn't pay attention. But now look, I asked a very simple question. What's the greatest rate of change? And what word is the same as rate of change? And nobody can say the answer.
I got it.
30 kids, not one can say the answer.
Dog. X.
Not a person. You think maybe you want to pay attention to this and write this down. Slope.
It's low.
Slope. Slope is the same exact thing as rate of change. So I look at this first one, letter B. What's the slope on letter B?
2x, 5.
5 over 2, right? Next, if I want to find the slope of this table, I just pick any 2 points. I like to try to pick positive points because I just think it's easier to work with positives.
Where did we what?
So remember, slope is the change in the y's, y from second point minus y from first, over x from second minus x from first. So I'm going to get 3 minus 0 over 6 minus 5, which is 3. Now, what's bigger, 5 over 2 or 3? 3. How do you know that 3 is bigger than 5 over 2? Davis?
You could put it into a mixed number.
Or decimal, right?
Or decimal.
Yeah, or a mixed number, either one. It would be 2.5 or 2.5, and 3 is clearly bigger than 2 point anything, okay? So, the biggest one is C. If we had a drawing here, we would just count the slope, right? We go up so many, over so many. But unfortunately, I forgot to draw one, so yo muy malo. All right, next question covers pretty much what yesterday's lesson was all about. What is the image of point 3, negative 4 after a dilation scale factor negative 4? Yesterday we talked about dilation. What are some of the important things to remember about a dilation? Ava?
Gets bigger.
Gets bigger or possibly smaller, but usually bigger. It changes size. That's the biggie. Okay. What else do you remember about a dilation?
You have to multiply.
Very good. You have to multiply. Those are the 2 biggies. The 2 biggies are what Ava said, the size changes. Usually it gets bigger, and what Matt said, you need to multiply. So the scale factor is negative 4. So let's do 3 comma negative 4 times negative 4, which means multiply each of them by negative 4. What's 3 times negative 4? Negative 12. Good. And then, what's negative 4 times negative 4?
Positive.
Positive 16. So negative 12, 16 is the correct answer. Okay? Any questions? Now listen, we didn't do anything in that do it that was difficult. So if you didn't get all of those do it questions right, then you need to up your game a little bit. Okay? And those kind of questions I would consider to be some of the easier kind of questions that you're going to get on the test that you take next week. Yes? Can you go to the bathroom? Let me get started with everybody first, and then we'll go over it on that. Okay, today's lesson. Today's lesson is all about this word called symmetry. You have symmetry. You do.
Thank you.
Yeah, absolutely. You are welcome. You can, our founding fathers referenced what our founding fathers called the creator in our founding documents. And that creator, Lenny, go ahead. That's your first, Lenny. It said, we are given certain rights, inalienable or unalienable rights by our creator, such as life, liberty, and the pursuit of happiness. Well, one of the other things your creator has given to you
Symmetry.
is symmetry. Michael, do you understand how often I see you looking around trying to communicate with others? It's a lot. I don't know if you realize you do it, but you do. And I hope you realize I'm not looking to bust chops. I'd rather not talk to you about this, but it happens all the time. You constantly like lean over on the desk and look over to Manny and Diane. I'm sure they'll tell you that you do it. And there it was just with Melvin, right? Focus, focus, focus. You're already a good math student. You could be a phenomenal math student. Like the kind of math student who makes $100 an hour when he gets older. If we learn to pay attention when the time is right to pay attention. Right? How'd you like a cool 100 every time you went to work for an hour?
100.
That's pretty cool. All right, now,
You went $1.
Alex. So, your creator has given you symmetry. See, if I take a line and I draw it right down the middle of it, I am the same on both sides. Eyeball, eyeball. Nostril, nostril. Could you imagine if I put this nostril up here with the eyeball?
Yes.
And what would happen if I sneezed? Oh, gross.
That'd be
I
pleasant.
get boogers in my eyes.
What?
But that very same creator was very smart to make sure that the nostrils were below the eyeballs. If we put the eyeballs down here, ooh, that'd be horrible. Can you imagine? Like, it's you, oh, God, I can't see. Oh, gross. Oh, like a booger in my eye. That would be the worst. Well, what if you like put your mouth up on top of your head? Did you ever think of what might happen if that happened?
You
just gets.
Right? What if you got sick?
Oh.
And like all your eyes just sting. You'd be like, oh! Yeah, have you ever like puke and it comes back up your nose?
Oh,
Yes.
Isn't that like the worst? You're like, oh!
It's so bad. I hate it.
It's just horrible, 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 horrible. So there's a lot of intelligence behind our design and how we were made. Now, eyeball, eyeball, nostril, nostril, mouth, mouth, ear, ear, right? Right, the heart is slightly to one side, but then you do have the two lungs. But are we perfectly symmetric? No, but we are mostly symmetric. And there's this concept called phenotype. Genotype, phenotype. Genotype is what your genetics are actually on the chromosomes and stuff, what your genes say. And the phenotype, right, is the outside. Our
We just learned that
phenotype
in
is
science.
symmetric.
We just learned that in science, that's why.
Excellent, there you go. Well, I'm actually reading a book all about it for the breeding of zebra and everything else. I'm trying to learn about it. So,
That's cool.
now, letters are often made symmetric. Now, not every letter, but lots of letters are. And there's two dominant types of symmetry we want to make you aware of at this particular point in time. One of those types of symmetry is what we call vertical line symmetry. I can draw a line right down the middle of that figure, and do you see how it's the same on both sides of that figure?
Yeah.
That's vertical line symmetry. Very good. By the way, vertical means up and down. Everybody take your hand, move it like this. Say that's vertical line symmetry. Vertical line symmetry. Very good. It's up and down. Now, the next one is horizontal line symmetry. And a really good example of horizontal line symmetry is the letter D. If I draw a line right through the middle of the D, it's the same on both sides. So that has horizontal line symmetry. It's a really good example of it. Now, a horizon, everybody move your hand like this. The horizon, Josh, think of it this way. You take your woman to the beach. And you see the sun setting on the horizon, right? So the horizon goes like this. So it's horizontal line symmetry. So just remember how the horizon looks, and you can remember horizontal. It goes in the same direction. All right, so does this, whatever letter that is, it looks like Arabic. Does this letter have vertical or horizontal line symmetry?
No.
No. What about A? Yeah, vertical, very good. What about T?
Horizontal.
Vertical.
I
No,
mean
not
vertical.
horizontal. So if I go horizontal, if I tried to do it, then this would go down there and there's nothing to match up with. What about E?
Horizontal.
Horizontal, definitely horizontal.
Vertical.
H,
Both.
both, very good. Here's vertical,
Also not.
here's horizontal.
Is there a different name for that?
Whoa.
Okay, what about, yeah, if it has both, it also has something we call rotational, but we won't go into that. We'll just say vertical and horizontal and leave it at that. Next one, what about the letter Y? Vertical, good. What about the letter P?
None.
None. What about the letter K?
None.
None, unless we go a step further, like if we're a little more specific and we write it like exactly
Yeah.
like this,
And it would be horrible.
then it would. But this, the way this guy's written,
It's weird.
no, so that one wouldn't have it, but K is not automatically not gonna have it. What about B?
Oh.
No,
No, horizontal.
horizontal. There's no vertical because this side's curved and this guy's flat, so if I tried to fold this over, it would have to match up with a straight line. Okay. Okay. Next. Another place where we can find symmetry is possibly on a graph. So let's do some graphing right now. Let's graph coordinates A, 5, 2, B, 7, 5, C, 1, 6. Everybody graph that right now. Very quickly, if you would. No clucking, right? Just get this done.
Bless you.
Thank you, thank you.
My triangles here now, the other way.
Okay, so there's triangle ABC. And now, and again, you guys cost yourself some time, and you're gonna miss the fact that we're gonna get through one example here. In the next class, we'll probably get through 3. And they'll learn it better, so in the future, try to settle down better. Reflect the triangle over the x-axis and call this triangle A prime, B prime, C prime. Whenever I do a reflection, I try to remember the term, or the phrase, count and repeat. What do I try to remember? Count and repeat. It's whenever there is a line, reflection, or reflection of any sort. Watch what I do. It says to reflect over, and it says it right here, the x-axis. Watch this, ready? 1, 2, 1, 2. I go to the x-axis and I repeat. What do you think I do for the B? 1, 2, 3, 4, 5. That's the count part. Now what do I do?
Repeat.
Repeat. 1, 2, 3, 4, 5. The C, what do I do? Count. 1, 2, 3, 4, 5, 6. Then what do I do? Repeat. 1, 2, 3, 4, 5, 6. And that's A prime, B prime, C prime. And now I have horizontal line symmetry over the x-axis. Okay?
It doesn't look.
Now, you can also flip it over the y-axis if you wanted to. Then you would count and repeat the distance to the y-axis. Okay, yesterday this side of the room went first, today this side of the room goes first. Put the calculator back.
Who's checking?
Okay, next group up.